The design of robots continues to evolve. Robots are getting smarter and better looking. It seems there's going to be no shortage of robots willing to work in outer space. This one, Robonaut, is exceptional. Robonaut was designed by engineers at NASA to work outside space vehicles, reducing the time astronauts have to spend on spacewalks. The pressure difference between the inside and the outside of the shuttle means that the astronaut must take time to adjust.
So prior to going outside, prior to putting that spacesuit on and going outside the shuttle, the astronauts go through something called pre-breathing, which is an exercise that lasts many hours, where they sit in a small area where the pressure is lowered to something like it's going to be inside the spacesuit. Goes through to avoid bends. He has to equalize the pressure in his lungs to what he's going to breathe outside. The difference in pressure to what you're breathing and what your body's essentially processing causes the bends, and it's of course a very, very bad condition.
Bring you over just a little more, Jerry. All right. A little bit further away from the structure now, Bob.
With Robonaut permanently based outside the craft, the astronaut has instant access to an assistant. But to control the robot, the operator must be able to see what it sees.
I sure do, Jerry. They're both tethered. Thank you.
Well, there are really at least two uses of the eyes in Robonaut. On the one hand, we're piping that video directly to a teleoperator, and he's wearing a helmet that has two displays. So whatever Robonaut sees with its eyes are displayed left and right with binocular vision. That gives the teleoperator depth perception, and that's extremely important. It's not an accident that our eyes are separated and forward-looking. It gives us great depth perception as an animal. When Robonaut sees something, it doesn't think anything right now. It's just pixels flowing past it. The most obvious thing for Robonaut, since it's a tool user, is to understand tools, to be able to see tools, to recognize them, ideally to anticipate the needs of an astronaut, to say, okay, he's at the point in the procedure where you normally ask for a wrench. I better get that wrench ready.
And like any self-respecting handyman, Robonaut is pretty good with his hands. This was a huge achievement from a design point of view.
The human hand is probably one of the most incredible machines anybody is ever going to have association with. The human form consists of 21 to 22 degrees of freedom, depending on which textbook you happen to be reading at the time. There's over 40 muscles actuating it, exceptionally high density of sensors in it. And trying to emulate that with basic mechanical elements is an extreme challenge. These three fingers here essentially is what we do most of our manipulation with, and if you notice, this is what you usually actuate a tool with or orient something. The remaining two fingers are what we use primarily for grasping or stabilizing a grasp, and this is essential for tool use.
So when the human wants the robot to reach out, all he has to do is reach his arm out. When he wants the robot to grab on with something, he reaches his hand out, and the robot hand emulates all that. That's a very intuitive, very natural way for the human to perform a task.
Robonaut's fingers are padded to give a good grip. They are also fitted with load cells to determine exactly how much pressure is being applied. The design team is working on tactile sensing, the ability of the hand to touch and distinguish different textures.
We see at least three roles there. One is kind of a Minuteman role. In an emergency, it could take hours to get an astronaut out. And in the case of a spacecraft emergency, that might be too long. Now, the emergency might require some special equipment. So let's say there's some impact or something that's caused a crack in the outside of the spacecraft. Robonaut might just go over and put its finger on the crack, keep the air from escaping while waiting for his teammate, the human, to egress with a spacesuit and a patch kit to fix the problem. A second role would be the ability to set up a work site and maybe to clean up a work site after an astronaut has done his job. We don't want to waste an astronaut's time hauling material back and forth across the space station. The last role that we're looking at is a surrogate to other worlds. Right now, humans really can't go above just a couple hundred miles off the surface of this Earth. And it's a big universe out there. There's a lot of universe higher than 200 miles off the surface of this planet. Robonaut could take us there virtually, allow us to do work, explore, way beyond human reach.
Now, if this has a familiar ring to it, that's because you've probably heard it all before.